Hello everyone, I am Prem Kumar. Welcome to Math JEE Academy. Today I am going to discuss with you the topic wise, subtopic wise concept. First is set, modulus and logarithmic related concept. So first today I am going to discuss 1.1 sets. Okay. Set is actually, the collection of well-defined object, right? You know that suppose I'm collecting the set of all butterflies, right? The butterflies, you can see it is countable, right? You can able to count, right? It's a finite or infinite, doesn't matter. You can count it, just put it into the basket, right? The same way you can see the collection of books, collection of, you can see collection of flowers. These are the set, right? So there are, you can see the set. This is the practical idea. Then how to convert this into mathematical way, right? How to convert this into mathematical way? First, we have to start with the sets. Okay. The sequence see the set is the collection of well-defined objects. Set is collection of well-defined objects, right? Okay. So what is that meaning? So for example, if I take the just butterflies, you can take this is set, right? So what is mean by well-defined? Let us take the set A. I'm just calling the set, name of the set is A. The set is consist of the elements, right? That curly braces you are using now within the bracket, right? Within the set, right? That is the elements you have to fill it here. So for example, here butterflies you can take. Butterflies. This is definitely set, right? It is well defined. Doesn't matter if it is countable or not countable, right? So just you can collect it, right? So for example, here, let's take set is collection of good teachers. Good teachers you can take. This is set, right? This is well defined, right? Good teachers you are collecting, right? So it is depends on the individual perceptions, right? How we can collect this good teachers. You may think I'm the good teachers. Somebody is telling that I'm not a good teachers, right? Maybe individual perceptions, right? Okay. And this is not well defined. It's not well defined. Well defined. Therefore, it is not a set. It is not a set. Not a set. You know, what are the things required for the set, right? The set, the elements are there, and the curly braces is actually like a basket, right? And the name of the set you can see capital letters, and the elements would be in the small letters, and the curly braces you can see just the box, right? Okay. So here curly braces there, it's like a basket, like a basket, and you can see if you take A, B, C, D, C, D, these are the elements, right? These are the elements you can take. And let's take capital letter A, B, C, D. You can see is the name of the set, right? You can see name of the set you can represent, right? Okay. So what are the tools is required here? What are the tools is required? You can see the elements here. Elements are separated by comma. Separated by comma. And second thing, the repetition is not allowed. Repetition is not allowed. And order is does not matter. Order does not matter. These three things is very important here. Let's take one example. Let's take A is equal to let's take A, E, I, O, U you can take. Okay. So this is actually English language, the collection of all the vowels, right? 5 vowels is there, right? You can see the elements are separated by the commas, right? Within the curly braces, you are writing the elements. Okay, fine. The elements are small letters, fine. And the repetition is not allowed. That means you can equivalently, suppose if I put two A's and two I you can put, right? This is same as this one, right? The repetition is not allowed. If it repeated, you can keep it at two letters are repeated, you keep it one letters, right? Repetition is not allowed, right? So all are same only, right? Okay, A. So one more letters I missed actually here, E, right? A, E is there, I is there, O is there, right? 1, 2, 3, 4, 5. Good. So then third thing is order doesn't matter. You can see I put here A is second, and here you can put here is A is last. Doesn't matter. You can put any order, right? For example, here, let's take A is equal to 1, 2, 3. It is same as 3, 2, 1. It is same as 2, 3, 1 also you can say. All are same. And it is same as 1, 1, 2, 2, 3, 3, right? 3, 3 also you can say. All are same because repetition is not allowed. So all are, because you can 2, 1 is repeating, 1, 1 you can take, 2, 2 you can there, 1, 2 you can take, 3, 3, 1, 3 you can take. I hope everyone understood, right? This is the basic idea of the set, right? So let's take another page. The representation of the set. Representation of set. There are two things is there. One is the roster form, and second thing is set builder form. Set builder form. Clear? Okay. So roster form, you can see, you can write explicitly, right? Write the elements explicitly, right? Explicitly. You can see the elements separated by the comma, right? This is abstract form. It's mathematical way, abstract form, right? For example, here, so let us take a set of all natural number. The name of the set here is n. The natural number start from 1, 2, 3. Okay, so this is natural number. Clear? You can see it is separated by the commas. You can see all the elements exactly, right? So set builder form, how to write? This is converted into set builder form. How to write? I'm just collection of all the elements in the natural number, right? Correct? Otherwise, you can do one thing. You're collecting all the elements such that x belongs to natural number, you can say, right? Let's take one more example. So let's take second example. Suppose I'm writing the elements 1 by 2 power 1. Okay, let's take 1 by 2 power 1, 1 by 2 square, 1 by 2 cube, 1 by 2 power 4, 1 by 2 power 5. This is your exact form of that, right? Is explicitly we can see the elements, right? Then how to convert this into set builder form, right? You can see students, the numerator you can see it's completely the same. The denominator you can see its power is varying, 2 power 1, 2 power 2, 2 power 3, right? Then how to write this one quickly? So 2 power n we can write. The vary here, n is varying, right? So n vary from where n is belongs to natural number, and n is vary from 1 to 5, right? 1 to 5 only you have to take. Clear? So you can write equivalently, right? Okay, fine. So next is we'll discuss the different different types of sets we can discuss, right? Next we'll discuss different types of sets, different types of set, right? let's take the set A. So let's take x belongs to real number such that x not equal to x. Let's take this set. So first observation, you can see this is the example for empty set. Empty set. Why it is empty set? Why it is empty set? You are collecting all the real number. Real number means what? Rational and irrational combinations, right? You can see square root, you can take, it is there or not in the set. So real number is there, but it is not there not in A, because square root 2 equal to square root 2, right? This is empty set, right? You can use this symbol or this symbol, you can use empty set, right? You are collecting the elements which is not equal to itself, right? It is not possible, therefore there is no element is possible, right? So first we are discussing that empty set, right? Okay, so you can use the symbol, this one or this symbol. So any other set you can give one more example. Let's take the same. A is equal to x belongs to, let's take natural number such that the natural number between 1 and 2 you can take. Is there any natural number is possible between 1 and 2? That's not possible, right? You can see the interval. This is 1, here is 2. So the interval is what actually is a part of real number. You should not include 1 and 2 here. Okay. So any real number you take, but it will be between 1 and 2. Right? This is a part of real number. But here is you are collecting from natural number. So the natural number is start from 1 to 3. So there is no 1. So 1 and 2 is not included. This is empty set, right? Okay. So let us discuss that interval here. A to B means what? Collection of all the real numbers such that the number is from A to B. It's a closed interval, right? You less than or equal to is there means you can include the endpoints, right? A, this is a complete real number, right? So A and B is included, part of the real number, right? It's a box, right? And if you take open interval means collection of all the real numbers such that the number is between A and B. Clear? It's the open interval, right? So that means you should not include the endpoints, right? You should not include the endpoints. Clear? Should not include. That means part of real number. For example, 0 to 1. So open interval means 0 and 1 not included, right? 0 to 1, that means included means 0 and 1 would be included, right? Okay, so you already know these things. Okay, this is empty set. That let's take the singleton set. Singleton set means what? The set consists of only one elements, right? Let's take the set here is x belongs to real number such that x square so equal to 0 you can take. So what elements is possible here? 0, 0 only, right? But the repetition is not allowed, so this consists of only one element is possible, right? Okay, let's take the second set. X belongs to real numbers such that x square, right, minus 4x plus 4 equal to 0. Let's take this quadratic polynomial, right? It's 2-degree polynomial. We can find at most 2 solution is possible, right? But here is the discriminant you can see minus b whole square, b square minus 4ac. A here is 1 and c is 4. So 16 minus 16, it will be 0. Discriminant 0 means what? We can find equal roots, right? So then you can equivalently how to write in the perfect square method x minus 2 whole square equal to 0, right? X square minus 4x plus 4 equivalently how to write? X minus 2 whole square. This is same as x is equal to 2. Therefore, the set is consist of 2. So how you can check this? You put 2 here. 2 square is 4. 4 minus 2 is what? 8, right? 2 square is, right? 4. 4 plus 4 is 8. So if you put here minus 8, it will be 0, right? So therefore singleton set, right? So next is we are going to discuss singleton set. After is let's take the finite set here. Finite set, you already know that the set consists of finite number of elements. Let's take A here is 1, 2, 3 up to n, right? The sum of there is a natural number, right? 1 to n. So equivalently we can write x belongs to natural number, right? Such that x vary from 1 to n. This also we can say 1 to n we can say, right? Fine. This is a finite number of elements is there, right? Infinite set already know, right? Infinite number of elements is there. Infinite set. Infinite set is what? Infinite number of element is there, right? So let's take this q. Q, you know, set of all rational number you can take. So what is the form? P by Q such that P and Q are belongs to integer. Q is non-zero, right? So collection of all the rational numbers, right? That is definitely infinite set, right? Okay. So what is that? Is ratio of integers correct? Correct? Ratio of integers. Q, suppose if it is 0, it is not defined, right? Therefore, this is infinite set, right? Next is equal set. Equal sets, right? What is equal set? So equal set means you have to understand before that what is subset. Before that you need to understand what is subset. Subset, right? Suppose here is A, this one, this is B, right? A is a subset of B, right? That means what? Every element in A will be there in B. If you pick any element in A, it will be there in B. So small basket will be consist of in the big basket, right? So that is A subset of B here. So for example here, equal sets. Let's take A is equal to 1, 2, 3, right? And let's take B is equal to 3, 2, 3, 1. These are equal sets or not? Definitely equal set. Why? Because if you take any element here, what is the element here in A? 1, 2, 3. If you pick any element in A, it will be there in B, right? The same way, if I take any elements in B, it will be there in A. Here order only changing, right? So equal set means what? The number of elements also same, the elements also equal. Elements should be equal, number of order. That means cardinality also same. Understood? So for example, if I take A is equal to 1, 2, 3, and let's take B is equal to P, Q, R, you can take. These two are equal sets? No. Equal sets means what? If you take any elements in A, it will be there in B. Any elements here, 1, 2, 3 only is there, but here is 1, 2, 3 is not there, therefore it is not equal sets, right? Understood? But second, next thing is equivalent set. Equivalent set means what? The cardinality would be same. The elements may not be equal, right? Okay. So you can see I will take another page. Equivalent set. Equivalent set. What is that equivalent set? Suppose A is equal to 1, 2, 3. So let's take B is equal to, let's take A, B, C you can take. These two sets are cardinality. You can see cardinality means what? Number of elements. Number of elements A is 3 and number of elements in B is 3. Therefore, both a number of elements are same. But here is equal set means or not equal, because every element is in A is not there in B. Therefore, it's not equal set but equivalent set. The number of elements in A, we can say n of A is equal to 3 and n of B here is 3. The order, number of elements here is same. If number of elements same and elements should not be same here. may or may not be, right? So therefore, what we can conclude? So n of a, the number of elements are same, therefore we can say equivalent sets. These two sets are equivalent set, right? Okay, let's take one example. So 1, 2, 3, 4. Let's take B is equal to P, Q, R. These two sets are equivalent sets or not? No. Why? Because here is 4 element is there, here 3 element is there. Cardinality is not same. Therefore, it is not equivalent set. But equal sets or not? No. Because every element is A, is not in B. Therefore, not equal set. This is not equal set. Not equal, not equivalent also. Not equivalent also. So, what we conclude generally, every equal set is equivalent or not? Yes. From this, what we can say? Every equal set is equivalent. Equivalent, right? And but all equivalent set may not be equal sets. May or may not be equal sets, right? We already discussed the example. If it equal sets means number of elements should be same and both the set and the elements also same, right? But equivalent sets, elements may not be same, but the number of elements should be same. Understood? Okay, therefore every equal set is equivalent set, but all equivalent sets may not be equal sets. Okay, I hope everyone understood, right? So next thing we are going to discuss that operations on the set, right? Operations on sets. Okay, so let's take the first one is union. Let's take two set A and B. How we are applying the operation on the number system? The same way you can apply the operations on the set theory also. Here two operations we will apply. One is union, second one is intersection. So the output here is A union B. How to define this? Your collection of all the set belongs to X such that X is belongs to A. X is any family of set, that means universal set, right? So A and B subset, you can see, you have to remember here, this is suppose universal set X, A here is this one, this is B, right? So A, either X belongs to A or X belongs to B. Just connecting all the elements in A and B right here. Either A or B. Whenever or you are using, you have to use union. Then here in the diagram, you can see Venn diagram, you can see this A union B is this portions, right? A union B. Okay. Suppose the first thing, suppose A is a subset of B, right? Suppose A here, this is B, right? This is A, this is B. What is A union B? Either A or B, right? Understood? For example, here A is equal to 1, 2, 3, and let's take B is equal to 1, 2, 3, 4. Every element in A will be there in B. Therefore, A is a subset of B. Okay. But what is the union here? A union B here is what? 1, 2, 3, 4, right? 4 only, right? So this complete thing is actually what? A subset of B means what? A union B is equal to B, right? This is equal to B. Understood? So this is complete things you can write. A union B. Second thing, suppose A intersection B is empty. A intersection B is empty means what? So disjoint, right? Suppose I am taking here. A is here is B. There is no common elements, right? Disjoints. What is A union B? A union B here is you You collection of elements in A and B separately. So this join these two elements of the sets, that is A union B, right? Okay, good. So next is, you can see the intersection, right? Next set is intersection. So what we can do, just take the operation, here is intersection, A and B you can take, A intersection B is the output, right? So what is the definition? Your collection of all the elements in X such that X belongs to A and X belongs to B. Both will be there. Then what is the diagram? You can see this is A, this is B, right? The intersection will be what? This portions, right? A intersection B. Suppose if you have A intersection B is empty, that means this way, right? There is no common elements, right? A, this is B, there is no common elements, right? And suppose A is subset of B is there. Suppose here A, this is B. The common elements is what? A, right? Suppose A is subset of B, so A intersection B is what? A, right? Because you can see this is your common elements, right? A intersection B. Because every elements in A would be there in B. So common element should be A only, right? Suppose if B is subset of A, B subset of A means the A intersection B is what? B, right? We can say clearly. So next is what we can do. We can find the difference of the two sets, right? Next is a difference of the two sets. Let's take A minus B, collection of all elements in X such that X belongs to A and X does not belongs to B. This is the meaning, right? That means what? You are having the two sets. You collect all the common elements, right? A and B, right? A and B. So you can see here. Let's take this is A, this is B, which is common elements here. This one, right? This is the common elements. Whenever they're asking A minus B, the difference of A and B, first you can see the common elements of A and B. So you have to remove from the common elements, remove from the first set. So you can see here, which is the common element here? This one, right? Red colored portions, A, right? You had to remove the common elements from A. If you remove it, you can see which portions will cover? This portions, right? This is your A minus B, right? Same way, you can see the B minus A. B minus A, how to write? Your collection of all elements in X such that X belongs to B and X does not belongs to A. Clear? So what is the portions here? This one, right? This is B minus A. What you can do? Just you can collection of common elements A and B. So B minus A means you have to remove the common elements from B. A minus B means what? You collection of common elements of A and B, you remove from the A. Clear? Okay. Now you can see, student. So how to write this one? You can see n of A minus B, how to write? Right? You can see in the screen, whole A is, you know that, whole A. So we need A minus B portions only is required. Take whole A, remove the n of A intersection B. We can write equivalently. Clear? And then second thing is, you can see n of B minus A. B minus A, what you can do? Collect all the elements in B. Collect all the elements in B. Remove the intersection. This way also we can write. Clear? Another way how to write, you can see A minus B, you can see A union B, how to write A union B, you can see n of A union B in this screen. A and B, how to write n of A minus B plus n of A intersection B plus n of B minus A also we can write. Clear? Okay, I hope everyone understood, right? In the screen only you can, everything you can see, right? Okay, so next, so what we can do, another way you can see, we need A minus B, B minus A is there. How to write the whole union you take, the remove the A intersection B, what will get? You can observe that A minus B union B minus A. This is how to write A minus B union, yellow color portions, right? A minus B union B minus A. What you can get here? The A union B you can take, A union B whole thing can take and remove the, you can see, remove the A intersection B, right? So we can write the symmetric difference, you can see symmetric difference of A and B, how to write? You can see students, A delta B you can write. This is A minus B union B minus A. This is equivalently A minus B union B minus A, how to write? So A union B minus A intersection B you can write. Clear? This way also we can write. Okay. So any other way you can say? That's all, no? Fine. Next we'll discuss the complement of the set, right? Next we'll discuss the complement of the set. Complement of set. Okay, let's take A complement. How to define a collection of elements in X such that X belongs to, so X belongs to X such that, where you can, so you have to remove this one, X belongs to X such that X does not belongs to A, right? Your collection of all the elements in the family, but it is not in A. That is, it is same as X minus A. X is the whole family. This is A, right? So A complement means what? You have to remove this except A, right? You have to remove these portions, right? X minus A. Clear? I hope everyone understood, right? X minus A. Fine. So then you can see the screen, the complement, right? The same way you can see the B complement also we can write. Suppose if you have the set, suppose A here, this is B, right? So what is A complement? A complement means what? Except A, remaining everything will be there. A complement, right? This is the black color portion is what? A complement, right? So you can see the screen. This is A, this is B, this is A, this is B here. So what is the B complement? You can see the B complement except B, right? Okay, 1 minute. I'll take another color. Except B. Remaining everything will be there, right? This is B complement. Understood? Okay, fine. So what else we can say here? You can see A minus B equivalently how to write in the screen. A minus B equivalently A intersection B complement we can write. Is it correct or not? How we can check this quickly? you can see student A is there, this is B, right? So A minus B means what? You collection of A and B combination, you write. You just common elements you take from A and B and remove from A, right? That is A minus B. This is A minus B, right? Okay, fine. Then you can see here B complement. You can see here, let us take, this is that. The B complement means what? You can use B complement. Other than that, B complement here is there, right? Clear? Other than the B, this is A, this is B, you can take B complement. B complement intersect with A. You can see the red color portion is there, no? You can intersect with the A means which portions is covered. This completely you can see here, this portions only, right? This portions only covered, right? Clear? This portions only covered. This is same as A minus B, right? Clear? The same way, B minus A equivalently we can write A intersection, sorry, you can write B intersection A complement, you can write. B intersection A complement we can write. Clear? Okay. Then you can see the A complement minus B complement. A complement minus B complement, how to write? So B minus A we can write. This is called De Morgan's law also, you can say, right? De Morgan's law, right? And you can see A union, A complement union B complement equivalently A. So this is how to write. A intersection B whole complement we can write. Okay, this is one, this is two. Third one, let's take A complement intersection B complement. This is same as A union B whole complement we can write. Here union means intersection, here intersection means union. Understood? So next class will continue this complete set of Venn diagram we'll discuss, okay? Because this short time we cannot discuss all the things. So next class will continue the set theory, okay? I hope everyone understood the set theory concept till now, okay? So you can watch this channel continuously. I will explain step by step with a clear explanation, okay? And if you like this video, please subscribe my channel. Don't be delay, right? Okay. And then you can see the past year paper, a playlist also available in the chapter wise, subtopic wise is available. Okay, you can watch it and you can excel in your mathematics, right? I hope everyone understood. So please subscribe my channel. Thank you everyone. Thank you.